have a marker. Really not adapting well to the environment. Not a chameleon. Okay. Do not freeze. When it does that, it freezes sometimes, and I'm going to get real angry if that happens. Okay. Not today, computer. A, B, C, D. We agree? Everyone's watching so I don't lose anyone? Because they often ask NPV or restriction questions on division. Because we stated for this one and this one, because those are in the denominator currently, correct? But with multiplication or division, with division, just like fractions, that second half flips, and then this becomes a multiplication, right? So in the next step, we would end up getting A over B times D over C, and now C is in the denominator. So D was in the denominator, C is now in the denominator. So we always state our NPVs for all three of them for only division, okay? Because non-permissible values, we've talked about this, and yesterday you guys explained why. Non-permissible values occur whenever we have a variable in a denominator, correct? Because if you have a variable in the denominator, we have to say what that variable can't be. That would make that denominator turn to 0, because we can't divide by 0. That's the reason why we state these. So we have to state it for this one and this one, but then we also have to state it for C because it will be in the denominator. Does that make sense? All right. That's it. Literally. That's the extra. We state non-permissible value for that top right. Other than that, we're going to flip and we do multiplication just like yesterday. So it's nothing crazy. Okay? So here it says C, D, B. See that? So let's look at number 1. Simplify each rational expression and state non-permissible values. So let's simplify them all first. So what do? We go to every numerator, every denominator, take out GCFs, and then see if there's difference in squares, right? So I'm going to go x minus 3. Can I do anything to that? No. So it's a binomial. It goes in its own brackets because it's sewn together by titanium string. 2x minus 5. Can I do anything to that? No. The 2x and the 5 are sewn together by titanium string, right? So I have to put that in its own brackets. And then I have divided by x plus 1. Can I do anything to that? No. Put in brackets sewn together with titanium string. And then an x. Now here's the catch with that division symbol. I did actually nothing other than put brackets around it, right? Now you can either flip it and state NPVs, or you can state them before. A lot of the time it's better to state them before because it still screams that this is division and you don't forget to do the top one, right? So I'm going to state it before, then flip. So I get 2x minus 5. So these are my restrictions. I get 2x minus 5 can't equal 0. 2x can't equal 5. X can't equal 5 over 2. And then I get x plus 1 can't equal 0. Subtract 1. X can't equal negative 1. And then x can't equal 0. I say it for all three. Do you see what I'm saying? Mm-hmm. See that? Okay. Then I flip and multiply. So I'm going to get x minus 3, 2x minus 5. So you invert and multiply what you're dividing by. So we're going to multiply x over x plus 1. And then when I have multiplication, I told you I can just do this, right? It's a great thing about multiplication. You can make a full numerator, full denominator, right? Draw that line through. Now, some people panic at this point. You're like, nothing cancels. I'm an idiot. No, nothing cancels. You're done. That's literally it. Nothing cancels, nothing cancels. You're not fully done. What do you need to put behind it? The restrictions. X can't equal 0, negative 1, 5 halves. Okay, so is it way different than multiplication, guys? No. You get an extra NPV and you flip it. It's multiplication, basically, right? So you guys try B and C. So in B, it's a division. When it's a division or a multiplication or a basic simplified, I'm always going to GCF, difference of squares, all the numerators, all the denominators. Like my rules have not changed yet. I've not changed a step, whether it's multiplication, division, or a basic simplification where it's just one numerator over one denominator. GCF, difference of squares. So this top left, so the numerator on the left is a binomial, so it's going to go in brackets. Okay. The denominator on the left is 3x, and then we get behind it x minus 3. And then the 3 and the x, thank you, are monomials, so they can go in their own brackets, right? Then we have a division symbol, and we have -5, which is a monomial, so it goes in its own brackets. And then the denominator we can take out as 6, and we're left with x minus 3, and the 6 is in its own bracket. Yeah? So we say NPVs for everything technically but the top left, the numerator on the left, right? Because that numerator on the right is going to become the denominator. Fun fact, it doesn't give you any NPs, it's just a number, but if it did, you would still say it. So we're going to go to B, C, and D and state restrictions. If it is just a number in a bracket, it doesn't cause a restriction. And you should understand why that is. Can 3 ever be 0? It's a 3, right? So that's why the number and the numerical values just by themselves in a monomial don't cause restrictions, because 3 can't be 0. It's a 3. And our issue is when the denominator turns to 0. So then we have x by itself. X can't equal 0. That one's done. If it was just an x squared or an x cubed or an x4 by itself, it would still be x can't equal 0. Because an x squared is just an x times an x, right? An x cubed would be an x times an x times an x, which results in x can't be 0. Okay? So if it's a monomial x, or x squared, or x cubed, or x4, the non-principal value is x can't equal 0. Make sure everyone's paying attention. If you're doing something else, you're not. All right. That's a hint to a few people. X minus 3 can't equal 0. Add 3 to both sides. X can't equal 3. Then we have -5. It's good. 6, that's fine. X minus 3 we already did. So that's it. Okay? A reminder, if your notes are out and something else is out with you, put that something else away. Okay. So, the right-hand side here, we need to flip it, correct? And then we're going to have multiplication. So, we're going to have x minus 5 over 3 x minus 3 multiplied by 6 x minus 3 all over -5. And then we can do this, right? Monomial, 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 monomial. So I put the monomials in blue. Yeah? Okay. And we say what's common in the numerator and denominator? Sometimes nothing. But this one has an x minus 3. That's common. I also have a 6 and a 3. Correct? Can I take something out of both of those? 3. 6 divided by 3 results in a 2. 3 divided by 3 results in a 1. And then I get people telling me that -5 and this -5 on the x minus 5 can cancel. The reason why I put them in different colors is to scream they cannot cancel each other, right? The blue ones are monomials. The black ones are binomials. Can a monomial ever cancel a binomial? Or vice versa? Monomials can cancel monomials. Blue for blue, black for black. Okay? So that's as good as it gets. Also, if you missed canceling something, no big deal. You can do it in the next step. You might still see that it's still there, right? Doesn't matter if you end up having to do an extra step, no. So we're going to get 2x minus 5 over x times -5, which is -5x. And then we follow behind with, comma, x can't equal 0, 3.
That's what I have.
Okay, we're going to look at 6. And by 6, I mean C. I don't know where that came from. You're welcome.
Why is there 2 in front of the x minus 5?
Because there was a 2 left behind.
So we can learn this to you guys.
You silly.
So that's technically right.
Silly goose.
Almost.
Technically right.
I'm also silly goose way up. There's other words, but most of them.
Silly goose. That's good. I'm going to use it now. I used to use silly goose a lot. Like silly goose. Person. Silly rabbit. Tricks are for kids. All right. C. What can I do at the top? The numerator on the left. Nothing. That's what I can do with it. So I'm going to write it's 2w, which is a monomial. Boom, 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 boom. The bottom left, the denominator on the left, I can take a 4w out. And I'm left with 6 plus w. 4w monomials, right? Whatever GCF you take out, just a hint, GCFs are monomials, right? It's just like one term being pulled out. 6w squared minus 6w, you can take out a 6 and a w, and we're left with w minus 1. 6w monomial. Denominator, I can take out an n. Ooh, I'm spelling the word. I see 9 and I said n because 9 starts with an n. You're welcome. I don't know what's going on. Someone call a doctor, I feel like. 9w squared. We get w plus what? 6. Thanks, guys. So many answers. So little time. Okay, we have lots of restrictions. So we are going to get, does 4 give me a restriction? No. W by itself can't equal 0. 6 plus w is w can't equal negative 6. I don't have room, so I'm not doing the math here. 6, does that cause me a problem? W can't equal 0, already done. W minus 1 gets me w can't equal 1. 9, no problems. W squared is the same as w can't equal 0. W plus 6 is negative 6, so I've already done them. If you get doubling up, everyone paying attention to me? Look at me. Look at me. If you get doubling up non-permissible values, that's a huge hint. There's probably going to be some canceling, correct? Because that would be the same factor. If you get the same non-permissible value in 2 spots, that's the same factor. So, all right. Next step is to flip and multiply. Okay, boom, we have division. Boom, we have multiplication, I mean. Okay, now some people get stuck on this. 6 plus w and w plus 6, are they the same? Yes, and the reason why they're the same is they have the same signs. So, side note, everyone put down pencils and everyone's paying attention because this is where I lose people. Okay, if I have w plus 6 and I have 6 plus w, the order doesn't matter because I can rearrange them, but the signs matter, right? So it's a positive w, positive 6, positive 6. They're the same, they can cancel. Yes? Okay, what if I have this? W minus 6, negative 6 plus w. They are the same. Positive w, negative 6, they can cancel. Okay, what about this? W minus 6, 6 minus w. They're the same, but what? The signs are different. So I could fix this by doing what? Take a negative 1 out of one of them. Often the numerator is easier because it sits up here. You guys like it up here better? So this would be a negative w, positive 6. And now do they match? Negative w, positive 6, then they can cancel. So you see the difference between what is actually the same and what is different? Okay. All right. So, we say our non-permissible values. The w can cancel off a w can cancel off one of these w's. W plus 6 and 6 plus w are gone. Then if you get stuck, say you don't like canceling around, right? I told you can take the numbers and put them together. So you can go 2 times 9 is 18, and then w, And then on the bottom, I would get 24 W minus 1. These are monomials. Is there something I can take out of 18 and 24? A 6, right? So if I take a 6 out, I'm left with 3W over 6 W minus 1. W can't equal 0, negative 6, 1.
You're taking a 6, so 6 times 4.
The student has become the teacher. The student has become the teacher. I even pressed the eraser to try and get this to go away quickly. Nah. Boom. All right. D. A minus 6. The bottom I can take out a 3A. Make sure you have equal signs. Can everyone go check on their paper that they have equal signs running on the left-hand side? Because you should be. They're all equal. So I get 3A, A plus 3. Oh, I haven't erased from that in. So whoops. Okay, divided by A plus 3 over 1, being a monomial. Okay, so we have 3 is not a problem. A can't equal 0. A plus 3 can't equal 0. So A can't equal negative 3 by moving that over. That's the same as that one, and then a 1. Okay. Then I flip and multiply. So I'm going to get A minus 6 over, hi Raymond. So we have 3A, A plus 3, times 1 over A plus 3. Now some people really want, guys, some of you really want things to cancel. Remember that on the test. Things should cancel. More often than not, they're not going to have just nothing cancel, right? But sometimes they don't. And I gave this one specifically in the notes because when A plus 3s are both in the bottom, people want to cancel them off because they match. But they don't cancel off. What do they become? A plus 3 squared. A can equal 0 or negative 3 squared. No. It has to do the whole thing, so it has to be on the outside. Now, you don't want to distribute the 2 into the brackets because that's not real. A plus 3 squared is A plus 3 times A plus 3, which is actually A squared plus 6A plus 9, not A squared plus 9, for those of you who distribute in. All right. Yeah. These 3, please. Your turn, example 2, and your turn. Go. Okay. So we have x cubed plus x squared over 16 divided by x squared plus x over 20x minus 10, because I don't want to start my work in the middle of the page. So I'm going to take an x squared out, and then I'm left with x plus 1, and the x squared is a monomial, over 16, which is a monomial, divided by x, which is a monomial, x plus 1, it's a binomial. Take out a 10, monomial, 2x minus 1. So our non-permissible values are going to be x can't equal, 16 doesn't give us anything, x is 0, 1 is negative 1, 10 gives us nothing, and 2x minus 1 is a half. All right, so then this equals x squared, x plus 1, over 16, times 10, 2x minus 1, all over x, x plus 1. Full numerator, full denominator. So this x can cancel off one of these. X plus 1 can cancel off that. 10 and 16, can I take anything out of them? 2, so this will be a 5, and this will be a 8. And then I think I'm done, but remember, if for some reason you don't take out the biggest thing, you can just do one more step and cancel more off, right? It's not the end of the world. So we're going to get 5, 2x minus 1 over 8. X can.
We have an X up there still. Remember, we only took the square
I
out.
have that there. I have no idea what you're talking about. X can equal 0, negative 1 and a half. Jeez, Fulton, pay more attention.
Close. On those Bible.
It was there the whole time. I have no idea what you're talking about.
I'm aware of it.
It wasn't there. It was not there. Okay. All right. Example 2. So the top we can take out a 15 and an x, and we're left with 2x plus 1. 15. Don't know what that just did. And x are in brackets. Okay, difference of squares. Some of you are thinking you have to square root the x squared and then square root the negative 9, and you're saying that can't happen. Remember, a difference of squares has to have a difference sign. That's a difference sign, not a negative 9. Okay? So the x squared is by itself, the 9 is by itself. The difference sign just means that I'm going to get a plus in the middle of one and a negative in the middle of the other. Square root of x squared is x. Square root of 9 is 3. Divided by, take out an x squared and left with 2x plus 1. Monomial. Take out an x and I'm left with x minus 3. So, our MPBs are from the plus 3, negative 3, from the x minus 3, positive 3, so plus or minus 3. From the x squared, it's 0. From the 2x plus 1, it's negative a half. From the x, it's 0, which we already have, and the x minus 3, it's 3, which we already have. So that's it. Okay, we rewrite it with multiplication. So we get 15x, 2x plus 1, all over x plus 3, x minus 1, or x minus 3, times x, x minus 3, over x squared, 2x plus 1. Squared and the x can cancel, x minus 3 and x minus 3 can cancel, 2x plus 1 and 2x plus 1 can cancel. Then I'm left with a 15x and an x plus 3 and an x. Oh, the x and the x can cancel, right? So then I'm left with 15 all over x plus 3. You don't need the x in brackets, but I just did that. X can't equal plus or minus 3, 0, negative a half. There's one x, there's two x's, that has two x's. So one here and one here gets me two x's, this has two x's, right? Okay, the last one, a lot of people paying attention to me right now because this is what I'm going to tell you. 99% of the time when you can't get anything to cancel, it's because you're missing the difference of squares. And the difference of squares that is often missed is one where it's something minus 1. Because you forget that 1's a perfect square. You remember 4 is a perfect square, you remember 9 is a perfect square, 16, 36, but 1 doesn't scream perfect square as much. So this 4x squared minus 1 is a difference of squares. I'm going to get 2x plus 1, 2x minus 1. The bottom is an x plus 2. Divided by, I can take a 2x out. I put the 2x plus 1. Aggressive erasing. And then the bottom, I can take out an 8. I'm going to be lazy. All right, x squared minus 4 here. So I'm going to get an 8. And then x plus 2x minus 2. All right. So my restrictions are x can't equal negative 2 from the x plus 2. 2 gets me nothing. X gets me 0. 2x minus 1 gets me negative a half. 8 gets me nothing. X plus 2 gets me negative 2. X minus 2 gets me plus 2. So then I'm left with 2x plus 1, 2x minus 1, x plus 2, times 8, x plus 2x minus 2, over 2x plus 1. The 2x plus 1 cancels, the x plus 2 cancels, the 8 becomes a 4, the 2 cancels off, and I'm left with 4, 2x minus 1, x minus 2, over x. X can't equal plus minus 2, 0, negative x.